Hi guys, Dr. B here, April 25th. Today's Saturday. Your colligative properties homework is due today at noon. Um, Today's homework that you're going to get is due on the 29th, next Wednesday. You also will receive a study guide for this Unit 8, Part 2, and you'll have a quiz on it on Friday, and then the following Monday will be an exam on May the 4th. So, hence Jaden's meme right there. And also, Joseph, you made a appearance as well. Alrighty, so we are going to talk about percentages regarding solutions. So there are a few terms we're going to have to keep in mind. So solute, solvent, and solution. So a solute is what is being dissolved. Solvent does the dissolving. And solute plus solvent is the solution. So the reason why we need to know these is because today's lecture is going to deal with these, but in a different way. You're going to have to be able to know what numbers go where when you're going to figure out these percentages. So one common way of expressing the relative amount of solute and solvent is through a percentage. So it can be expressed in three different ways: a mass to mass percent, a volume to volume percent, and a mass to volume percent. So when you look at these things, when we talk about these things, we're going to get an example, we're going to get a formula, if you will, and yeah, it's pretty standard actually. So which shouldn't be too bad. Before we do that, we got to discuss a certain property. It's called density. It does not change for a given substance. So between these two right here, which one is it? If it's not going to change, regardless of how much you have of something, so it's going to be extensive or intensive. And hopefully you're saying intensive because extensive depends on how much you have of something. So intensive is what density is. Density is a type of intensive property. And it's the relationship between the mass of something and how much space it takes up its volume. So the formula for density is, so you put density equals mass over volume. If you have objects that take up the same space, meaning the volume, but have different masses, they're going to have different densities. So if you have a bigger mass between two items, but they have the same volume, that means it's going to have a bigger density. And density can be used in some way in either of the three types of percentages we're going to talk about today. But before we get into that, I want you to watch the density demo that I have posted that I did at home with Diet Coke and Dr. Pepper cans. I want you to see that, just something to think about in terms of this topic. So hopefully you watched it. If not, you're kind of cheating by reading this. So both the Diet Coke and Coke cans contain the same amount of liquid, about 222 milliliters. Mostly water, of course, but the main difference is the sweetener, whatever sweetens this soda. So regular Coke contains about 197 milliliters of water and 197, that should actually be 25 grams of sugar. So therefore, 197 plus 25, that's 222 grams. What we did was we converted the 222 milliliters to grams, like that. However, if the Diet Coke can had only 0.2 grams, you notice that there's quite a difference between the 25 grams and the 0.2 grams of aspartame. The reason why the Diet Coke floated was because it actually has less amount of sugar or sweetener in it. Diet Coke only has 0.2 grams while regular Coke has 25 grams. And if you look here on the bottom, the two densities, you'll see that between the two of them, Diet Coke has about the same or is a little bit has a density that's a little bit smaller than water, so that's why it floats. Regular Coke is a little bit above 1, therefore it's going to sink a little bit. And you saw that Dr. Pepper, it hit the bottom really quickly. So, and it's kind of stayed down there. So for some reason that one is more dense compared to Coke, which is more dense than Diet Coke. Alrighty, so mass percentage of a solution. It's the mass of the solute divided by the mass of the solution multiplied by 100. So here's the way to look at it. So we can say grams, mass percent equals grams of solute divided by grams of solute plus grams of solvent. So that's basically the grams of the solution times 100. So what you need to do and make sure is that you add up the masses of the solute and the solvent that's given in the problem. For example, a solution is prepared by dissolving 25.2 grams of sodium chloride in 250 grams of water. Calculate the mass percent of the solution. So you can do mass to mass percent equals 25.2 grams on top, then 25.2 grams plus 250 grams on the bottom, then times 100, and you're going to end up with times 100. So we have, let's do 3 sig figs for this, 9.15697 blah blah blah. So 9.16%. Pretty much that's all it is. You just got to be able to recognize what it is based on the question.